let's start with a brief review of what we've done so far in terms of comparing two proportions. First of all, we need to look and figure out what the explanatory variable is. And right now, we're only working with categorical. We will soon be working with quantitative variables, but not at this point. The response variable also has to be categorical, and with two categories being success and failure. Then we can compare the proportion or probability of success across different groups. So this is what makes it different than what we did earlier. Here we have groups, two different groups, a control group and then our test group, or we looked at the dolphin group, which in the case was either swimming with dolphins to see if there was substantial improvement in depression, mild to moderate depression, if there was substantial improvement with swimming with dolphins, compared to swimming without dolphins. Now remember, the hypotheses in this case involve two pies. Our null hypotheses, in other words, nothing interesting happened. It was just random chance. So we have pi sub d equal to pi sub nd. So remember, those parameters are just the same. Versus the alternate hypotheses, we didn't say whether one was better than the other, just whether they were different, whether there was improvement in one, substantial improvement in one or the other group. What we did was we used simulation using cards and assumed that the responses, the outcomes, would have happened anyway, so by chance. And we explored what could have happened by chance alone and how many successes would have landed in each group. And that way we generated that null distribution, because remember, we want to generate the distribution that nothing special is happening, okay? So we always, when we're simulating, just to remind everyone, whenever we simulate that the null distribution is true. In other words, nothing special is happening, it's by chance alone. So essentially, the conditions don't matter. We're not worried about what was in the study. We're just trying to figure out, given what information we have, we can generate this distribution, the distribution that whatever's happening is just by random chance. So let's start another example, just to make sure we're comfortable with all these. I would like you to pause the video and take a few moments and fill in A through, let's see, A through F, and then come back. So hopefully you paused the video, read the description, and then filled it out. Really quickly, I just want to look at it. Mythbusters, I love that show. I actually watched it quite a bit with my son when he was young. They would look at something to see if they could find out whether something was interesting. Some of my favorites, well, I have a lot of favorites actually, so I won't bother going there, but if you get a chance to watch this episode, it is fun to watch. Let's see. So there were 50 participants at a flea market, and then they were asked to sit in a room for a short length of time. So 50 participants, so we know our sample size already. Every 2 out of the 3 participants was given a yawn seed stimulus. That is, they saw one of the researchers yawn. And then all participants were observed to see whether or not they yawned during some period of time. At the completion of the data analysis, the Mythbusters team said there's little doubt if it is contagious. But do their data actually provide evidence to say so? So we want to proceed with this study, and hopefully you list the observational unit as each participant, or each participant from at the flea market. Either one is good. The explanatory variable. Now remember, what's going in and what's coming out. So what went in was whether or not they were given a yawn seed. In other words, whether they saw someone yawn, so it's categorical. And the response variable is whether or not they yawned themselves. So the input being, okay, we start with, did they see someone yawn? And then when they were observed, did they yawn or not? So success or failure, I would say in this case that for this, I would say success, personally, I'm choosing success as that yes, they yawned. Now, is it a randomized experiment? Well, Because the researchers used a random mechanism, they used 1 out of the 3. So they didn't line, we're assuming they're just sitting in the room and they just had people come in. They chose a random mechanism, literally 1 out of 3, to impose the stimulus. So yeah, it's looking pretty good. Describing words and symbols the parameters of interest. So hopefully you did a stimulus, no stimulus, or something similar to that. Now on an exam, obviously, I'll probably give you what the parameters would be and a letter, unless it is a fill in the blank sort of, well, a short answer. In this case, though, I'd probably tell you what I'd like you to use so that your notation will be consistent with what's going on throughout the problem. So pi sub s, remember pi is a parameter. So it's the long-term proportion of yawners when given a yawn seed stimulus. So they were shown someone who was yawning, and then the pi ns is the no stimulus. The hypothesis. So remember, this first one, the null hypothesis, nothing is happening. Whether or not they see someone yawn, it doesn't matter. They are going to yawn roughly the same number of times. So yawning is not contagious. On the other hand, what they're interested in is whether, if they're given a stimulus, do they yawn more? So is yawning contagious? And that's our alternate hypothesis. So the one thing I didn't do here that I absolutely must and should have written earlier was my null hypothesis and my alternate hypothesis. Why is this important? You always want to make sure you fully describe what's going on. So I want to state that specifically this is the null, all right? So there's no confusion, and that this is my alternate hypothesis. Can we just flip those randomly? No. In terms of could I put the greater than up there? Absolutely not. Remember, the null hypothesis, H sub 0, is that absolutely nothing interesting is happening. So it turns out that 10 of the 34 in the stimulus group yawned, whereas only 4 out of the 16 in the no stimulus group yawned. Organize the data in the, let's try that, in the 2 by 2 table below. So take a moment, pause, and see if you can complete this table. So hopefully your table is that. I always start with, I know the total needs to be 50 because the sample size was 50. So I personally filled that in first. And then I went here and I try to fill in a column or a row at a time. 10 of the 34 in the stimulus group yawned. So stimulus, yes. So I'm going to look at this column. 10 yawned after, and then out of the 34. So then I know that what's left over has to be in this box here. That's 24, and so on. One of the big ways to check if you're doing this table, especially if you're doing it on an exam or in a homework, is if you can add across, right? So 10 plus 4 gives us 14 total for whether they yawned, and no, 24 plus the 12 is 36. These should add, they both should add down and across to total 50, okay? So that's something to keep in mind. You need to be really careful that your numbers actually all work. So once again, I know I keep saying this, pause this. What I'm trying to do is get you to practice and then hear me talk about it, and hopefully you get to the same thing, and I'm reinforcing what you've done. All right, so see if you can come up with p hat sub s and up until key question. So p hat sub s, sample the proportion of yawners in the stimulus group. As soon as I see in the stimulus group, I know I'm going to want to go and look at this first column. We know we had 10 out of the 34. Of course, I used my calculator and I got 0.294. In the no stimulus group, we want to know the sample proportion of yawners. All right, so we're going to look at no. There were 16 total. 4 did not yawn. We see that right there. 4 did not yawn, do the division, and we get 0.25. Now, remember, we're looking for we want to look at the observed differences. That's, remember, when we talked about looking at the null distribution, whether they were the same or not. So the observed difference in proportion of yawners between the stimulus and no stimulus groups is you take the numbers that you found above, subtract them, and I got 0.044. So the key question is, if yawning is not contagious, that is, if yawn stimulus has no effect, so the null hypothesis, it's just random chance, how surprising would it be to see this difference of 0.044? So what is one way that we can measure it? Remember, what we want to do is create a null distribution for the values of p hat sub s minus p hat sub ns that could have been by chance if the yawn stimulus has no effect. So we can do it by a tactile simulation, just like we did with the dolphins. So this is very similar to what we did for the dolphin study. Total number of cards, total cards needed. Well, remember, we're going to need the total. If you get confused, go back up and think, well, how many participants did we have? Well, we had 50 total. A total set in the study, and we also can see it in the chart because there were 50 participants. What would you write on how many cards? Now, once again, I would like you to pause and take a minute and see if you can write out 2 through 7. Okay, so hopefully what you did is, what would you write on how many cards? And you could choose, you could do this either way. Just need one, you need this, you could have written 3 under 2 and 2s under 3s. Either way, it would be fine. But what you want to do is write yawn on 14 cards. Well, how did I know that? That's because I went up here and said, okay, I need, let's see here, how can I do this? There we go. I need 14 yawns and 36 no yawns. And hopefully you all agree with that, because we're looking at the totals right now, right? So we wrote, out of the study, there was 14 total people who yawned, regardless of the stimulus, right? Whether there was stimulus or no, and 36 who did not yawn. And we wrote those in the cards, and that's where we get those numbers from. All right, so there's the start. Then we're going to take those cards, shuffle them all together, and deal them into 2 piles. Now, how many are in each pile? And this is what we're doing here, and you didn't have to write this, obviously, but we're trying to do is mimic what happened in the study. We're trying here to generate a null distribution. In other words, these answers that we got came up randomly. So 34, so we're going to deal into 2 piles, 34 into a stimulus pile, 16 into a no stimulus pile. Well, how am I going to know that? Once again, I'm going to go back up and look and say, oh, okay, here we go. I know that I've got 34 and 16, okay? Because there's 34 in the stimulus, it's 16 in the no stimulus pile. So if you don't see that, make sure you go back up and double check and make sure you're understanding where we got those from. Now what you're going to have to do is record, is count, then do the counts like we did before, find the proportions, the p hat sub s minus, and then take the difference minus p hat sub ns for that shuffled data. All right, so like we did with the dolphin study, we would do that, and then we would repeat that over and over and over again to generate the null distribution. In the end, we want to determine what proportion of the repetitions that we did had p hat sub s minus p hat sub ns greater than or equal to 0.44, because remember, that comes from what happened in the study. And we want to see how unusual this number is compared to the null distribution. But let's be honest, that's time consuming. I didn't even show you the calculation this time. Remember, we did that with the, we did do the calculation for this here for 5, but it takes a long time. So what's another way that we could generate this null distribution? Well, hopefully you think applet, because applets are a great way to help us generate these null distributions. Now we're going to use we're going to use the analyzing, two-way tables or the randomization test for categorical response, and they're both under statistical inference and the applets. So I actually went in, I clicked 2 by 2, make sure that was clicked. Hopefully these were all, each of these boxes was empty. If not, you want to clear table. And then I put in what we had above. So if you scroll up on your sheet, or if you're going to probably flip, you'll notice that this matches the table that we had above, except of course that this is generic. It says group A, group B, success, and failure. So then the sample data comes up. Looking at it right away, if I just look at these 2 bar charts, just looking at them, I think they don't look all that much different. But remember, it's not just a matter of whether they look different. We want to see if it still could be, they could be statistically significant, the difference. But we don't know. We can't say. My gut is, well, no, probably not. But gut isn't a good way to go. All right, you're going to want to actually generate the statistic here. Is difference in proportions. You want to make sure you choose that. And remember before we did 1,000 repetitions. So instead of course, shuffling by hand, dealing out the different piles, calculating the proportions of what you have, it's done automatically for us. So we put in we have all of our data. It generated the bar chart for us. I did 1,000 shuffles. And then I said, well, let's look at, remember, we want to look at whenever the proportion is greater than 0.44. Now, remember, this is the null distribution. We expect it to be centered around 0, right? Because they're saying that the parameters are equal to each other. Stimulus versus non-stimulus, so the pi's are the same long run for many, many repetitions. So we'd expect the mean, so pi sub s minus pi ns, we expect it to be 0 long run if this was by random chance. Hopefully that's very natural for you at this point. Wow, that's hard to read, pardon me. Remember, can we ever prove this random chance? No, absolutely not. All right, so I did that, I clicked count, and then all of this came up, okay? Of course, it shows you what the most recent shuffle is and where that is, and if you're curious what that is, that's that little blue thing right there, if you can see it. So before stating any conclusions or anything, I'm just looking at this thinking, wow, by a random chance alone, that sure, I don't see any support there for the null hypothesis. 0.044 does not look surprising to have happened by chance. It's well within this bulk of the null distribution here. So where is the observed difference in proportions on the graph of the null distribution, and which region represents the p-value? And that's already circled that, and we can see it there. So that's this up here. So interpret the p-value in the context of the study. Remember, when we interpret the p-value, we should include the null hypothesis, the observed result, and is it or more surprising direction of the alternate hypothesis, if it is surprising at all. Finally, of course, so interpreting the p-value, is that where we end? No. At the end, what we're going to do is formulate a conclusion for this study. Ideally, at this point, you would pause the video and try this for yourself, okay? Even if you don't fully write it out, say it to yourself to see if you can come up with interpreting the p-value and formulate a conclusion. And I'll be back and you'll be able to see those in just a moment. So I said a minute, of course for you it's like a second because I paused recording. So remember, we're going to interpret the p-value. We want to include the null hypothesis, the observed results, and more surprising, the direction or whatever we find with the alternate hypothesis in relation to the alternate hypothesis. So first of all, we need the p-value. So if I go back up here, do we have a p-value? Yes, the p-value is right here. It's 0.53 because remember it takes the count and it calculates it for us. So if yawning is not contagious, it's equally likely to yawn regardless of the stimulus or not. We would observe the proportion of yawners in the stimulus group of 34 to be larger than the proportion of yawners in the no stimulus group of 16 by 0.044 or more, about 53% of the time. Ugh. Okay, that's the p-value from the outlet. So let's choose things here. Number one, the null hypothesis. So if yawning is not contagious, and we talked a little bit more about it, so there is number one. We would observe, so the observed result, we would observe the proportion of yawners in the stimulus group. And so this is all of number two here. We see that. And the observed results. About 53% of the time. So I look at that, I'm like, it's like, well, I didn't put in or more surprising. Well, yeah, we tell you when it's going to happen. So I could have said 0.44 or more surprising about 53% of the time. All right, so I just didn't use surprising. I just didn't, because it's not, looking at the data, it wasn't surprising. But it's just where we state what the result is, our observed result, and then we say, we talk about with the correct, if it had been less, we would say less of the time, but in this case, it was more, so 53% or more. So that's looking at our p-value. That's interpreting the p-value. So that was number 3 here. But remember, we also want to look at significance. When we do a conclusion for a study, we want to look at significance, causation, and generalizability. So the p-value of 0.53 is not small. It's not even close to small. So the results are not statistically significant. So I'm going to do S right here for statistically significant. Even though the study was a randomized experiment, we have no evidence to conclude cause and effect. So we did talk about whether we could, what we could assume, but we have nothing to, we can't say anything because there's a lack of statistically significant results. Now, what you absolutely cannot do is at this point say, well, but since I didn't find anything, didn't I find support for it just being random? No, remember there could be so many other factors involved. We can't find evidence for the null hypothesis, all right? We don't have evidence that yawning is not contagious. We did not find that. We just found that with what we did, it wasn't contagious. So our alternate hypothesis based on what we did not cause yawning. But could other things? Sure. So we didn't find that, even though it wasn't randomized, we have no evidence to conclude cause and effect because lack of statistically significant results. We cannot find evidence for the null hypothesis. And I know I keep saying that, but it's one of those things that's where students usually go wrong. Finally, if we did have something to talk about, our generalizability, given the way it was done, we could generalize to folks like those similar in the study, similar age, socioeconomic status, health, etc. So that's the end for this. So this was just hopefully another, what you took away was another example of what we had done with the dolphins, looking at it, pulling everything together. Next time, we're going to go further with this.